It is one of the most perplexing questions in modern space exploration because we simply cannot say what really lies inside black holes. And yet the answer could actually be so simple. Some experts are firmly convinced that it's simply us. According to them, it's not only possible, but extremely likely that our universe was born in the heart of one of these massive monsters. Spectacularly, this idea was recently backed up by a new observation from the James Webb Telescope. But how is that even possible? After all, these colossal objects are known for destroying literally everything. Or are they? Well, not necessarily. So stay tuned until the end if you want to know whether you are currently inside a black hole. The universe is a wondrous architect. After all, it has created places that are so extreme that they plunge everything around them into utter chaos. Objects that swallow everything that comes too close to them and from which there is no escape, and which turn the world we know upside down. These objects are known to us as black holes. But not all black holes are the same. At the bottom of the cosmic ladder are stellar black holes. These are formed by the collapse of massive stars. More precisely, the celestial body ejects its outer layers in an explosive supernova. Once its internal nuclear fuel has been exhausted, the remaining star core collapses under its own gravitational pressure to form a stellar black hole, which usually weighs between 3 and 10 solar masses. However, things are much more impressive in the case of supermassive black holes. As their name suggests, these are not only significantly heavier than their stellar counterparts with millions or even billions of times the mass of the Sun, but also many times more influential. It's now considered certain that virtually every galaxy center is adorned by such a monster, including the heart of our Milky Way, where Sagittarius A, weighing around 4.3 million solar masses, sits enthroned. However, when it comes to the exact origins of these galactic centers, experts can only speculate. They believe that these giants were either formed by the merger and long-term growth of smaller black holes or by the direct collapse of large gas clouds in the early universe. What is undisputed, however, is that the existence of such a colossus does not pass without leaving a trace on its surroundings. Quite the contrary. In fact, supermassive black holes can actually form entire galaxy structures and are also responsible for the activity of quasars, which are among the most luminous objects in the entire cosmos. Their event horizon can be millions of kilometers wide on the scale of planetary orbits. But beyond that, black holes are known for one thing above all else, irrevocably devouring everything that crosses their event horizon: cosmic destruction machines. This elemental force of black holes is in turn due to their incomparable compactness. If one of these objects had the same mass as Earth, it would have a diameter of just 9 millimeters due to compression. We are therefore dealing with extreme compactness, which means that the gravitational pull in the immediate vicinity of black holes is so strong that nothing can cross their event horizon from the inside out. And we really mean nothing. No information, no radiation, and certainly no matter. And since this also applies to light, the actual black hole is invisible to our eyes. All we see are the brutal forces at work in its vicinity. And excitingly, we can now actually do that. In 2019, astronomers succeeded in photographing a black hole for the first time using the Event Horizon Telescope. It's located in the center of the galaxy Messier 87, some 55 million light-years away, and weighs an impressive 6.5 billion solar masses. Our black hole was also captured on camera a few years ago. But how is that actually possible? How could it be possible that supermassive black holes can sit at the centers of galaxies without completely destroying them? Well, it's true that these monsters devour entire planets, stars, and gigantic cloud formations. But for this to happen, these objects must also come into close contact with the black hole's event horizon. Outside this ominous zone, however, and this is the amazing thing, these gravitational monsters behave like any other massive body, which is why they can easily be orbited by other celestial bodies in stable orbits. But assuming that an object does ultimately fall into the fatal grip of a black hole, what wondrous world awaits it inside? In the belly of the gravity monster, We know pretty much what happens outside a black hole as soon as you approach its event horizon and get within touching distance of the infamous point of no return. And even if the mechanisms behind the formation of supermassive black holes still remain a mystery, we do at least have a theoretical answer to the question of what lies dormant inside these surreal extremities of the cosmos. To put it clearly, within the event horizon, the laws of physics are turned upside down. Experts' calculations suggest that the structure of space-time is twisted, chaotic, or altered in some other exotic way. Furthermore, it's said that a so-called singularity prevails inside black holes. In other words, a point where density is infinitely high, gravity is infinitely strong, and space-time is infinitely curved. And that is problematic, to say the least. Singularities cause the laws of physics, as we know them, to break down. Einstein's general theory of relativity in particular can no longer make any meaningful predictions here. And so it is that many researchers fundamentally question this point of infinite density at the center due to the tricky starting point. However, there is no question that an astronaut caught in the pool of a black hole would be spaghettified. And yes, that really is the official term. And for a very simple reason. The enormous tidal forces would deform and stretch the astronaut's body so grotesquely that it would visibly resemble the famous Italian pasta. However, this does not only apply to us humans, but to all objects, which is why it is not possible to send an unmanned probe into the interior of a black hole to uncover its secrets. Since researchers cannot say with absolute certainty what really lies beyond the event horizon, they must venture into the realm of exciting theories. And on paper, it's possible that black and white holes could form a wormhole together. This means that the matter swallowed by a black hole is ejected by the white hole in another part of the universe, or perhaps even in a completely different cosmos. This applies to both the spatial and temporal levels, including the past. And as you can probably guess, white holes are the hypothetical counterparts to black holes. So we're dealing here with structures that constantly eject matter, while at the same time it is impossible to cross their event horizon from the outside to the inside. However, these objects also come with a huge catch. Although they are valid mathematical solutions to the equations of general relativity, their actual existence has not yet been proven. Theoretical physicists such as Nikodem Poplavsky, however, have a completely different answer to the question of what is hidden inside a black hole, namely ourselves. Where conventional Big Bang theory has reached its limits, there is a theory that a cosmic seed matures in a black hole. As soon as the sucked-in matter reaches a point where it cannot be compressed any further, the seed bursts open, paving the way for the unfolding of a new cosmos. In other words, a black hole could represent a transitional state between two universes. If it were possible to survive a detour into the interior of this gravitational monster unscathed, one might find oneself in another world. There is no question that this hypothesis sounds rather unconventional. And that is precisely why it's all the more surprising that the James Webb Telescope recently discovered something that actually supports this idea. But what did Webb find? Well, first, a team led by Loa Shamir from Kansas State University analyzed more than 260 early galaxies in the so-called Jade Field, which Webb had previously examined. And indeed, a surprising detail caught the experts' attention. The majority of the objects observed rotate in the same direction. More precisely, 2/3 of the galaxies rotated clockwise and only 1/3 in the opposite direction. But how does this movement pattern lead to the conclusion that we are inside a black hole? Well, it's quite simple. In a random universe, one would expect the directions of rotation of the galaxies to be evenly distributed. And following Poplavsky's thesis, one explanation for this is that our cosmos originated in a black hole that already had its own rotation. According to experts, this idea is compatible with Schwarzschild cosmology, which posits that our entire universe is the interior of a black hole in a larger mother universe. In this context, each black hole would represent the transition to a sub-universe or baby universe. While the rotation of the original black hole would influence the preferred direction of rotation of the galaxies in the newly formed universe. And your preferred click direction can now influence your new subscription. Simply press the thumbs up and subscribe to never miss a new video again. We'll see you soon.